This is the lesson on polynomial functions. We will be discussing the degree of a polynomial and what the leading coefficient means, as well as something called end behavior. So the degree of the polynomial is just the highest exponent. Now if there's more than one exponent, so for example if you have an a squared b to the third, this degree would be 5 because we would take the 2 plus the 3 to get 5. If we just had an x to the sixth, that degree would be 6. So it's whatever the highest exponent is. That's your degree of the polynomial. The leading coefficient then is the coefficient that is attached to the highest exponent. And so we'll take a look at a couple of examples here. So we're going to find the degree and the leading coefficient. So our first one, 7x to the sixth minus x to the third minus 1 over x. First off, we can clearly see that this x to the sixth is the highest exponent, so that would be our degree. Our degree will be 6. And then the leading coefficient, which we will abbreviate LC, is the coefficient attached to it, which in this case is 7. Alright, our next example here, 1/2 x squared plus 2x to the third minus x to the fifth. Our highest exponent here is that x to the fifth, so the degree is 5. And then the leading coefficient is the number attached to the x to the fifth, which would be a -1. Okay, so whatever values we get for these two are actually going to help distinguish what our graphs will look like, and we will get to that a little bit later on in this lesson. So this is end behavior. So here are the 4 general ways in which a graph is going to look. And the end behavior is going to be discussing what happens as x approaches infinity, both positive infinity and negative infinity. So what we're going to do here is we are going to describe end behavior in a very general way. This is going to be our outline of how we describe end behavior. F of x approaches something as x approaches infinity, and f of x approaches something else as x approaches negative infinity. When we approach it this way, we use this outline every single time, we just need to figure out what these two blank spaces are. And when we're dealing with f of x here, remember we can view this as a y. So we're looking at the y direction. So relating this to this first graph over here, what this is saying is as x approaches infinity, so that's to the positive direction. So over here on the positive side of the graph, what is happening? Well, here on the positive side of the graph, notice that this arrow is going down. So for this first graph, we would say f of x approaches negative infinity as x approaches infinity. And we're saying negative infinity there because that graph was going down. The second portion of it to it then is what happens as x approaches negative infinity. So that would be on the left-hand side of this graph. So on the left-hand side of this graph, notice that this arrow is going up. So f of x would approach positive infinity as x approaches negative infinity. So that's how we describe that end behavior of the graph. So let's look at this second example right beneath it. We're going to outline the same exact thing. So f of x approaches something as x approaches infinity, and f of x approaches something as x approaches negative infinity. And we're going to do it the same way. So here for the second graph, as x approaches infinity, that's a positive side. So this is the positive side of the graph. Notice this graph is going up, so we're going to say that f of x approaches infinity. As x approaches negative infinity here, that's the left-hand side of this graph. Notice that that left-hand side is going down, so going down would be negative infinity. So that's end behavior. Alright, we'll do these next two ones as well. So we're going to do the same exact layout. f of x approaches something as x approaches infinity. F of x approaches something as x approaches negative infinity. So here for the third graph, as x approaches positive infinity, that's on the right-hand side, and notice on the right-hand side this arrow is going down, so that means f of x approaches negative infinity. Same thing on the left-hand side, as x approaches negative infinity, notice that this graph is going down, so on the left-hand side this approaches negative infinity. Alright, now we'll do the same exact layout for the fourth one. F of x approaches what as x approaches infinity, and f of x approaches what as x approaches negative infinity. Well, once again, if we look, both on the right-hand side and the left-hand side, our arrows are going up, so that means for both of these would be approaching positive infinity, regardless if we're on the right side of the graph or the left side. So that's end behavior. The other thing that I want us to be able to identify is what the leading coefficient is. Okay, so to determine the leading coefficient, we just simply look at the right-hand side of the graph, and the right-hand side of the graph, if it goes up, the leading coefficient is positive. If it goes down, the leading coefficient is negative. So for this graph, the leading coefficient would be negative because the right-hand side is going down. So for these top two graphs, the leading coefficient is negative. For the bottom two graphs, the leading coefficient is positive because the right-hand side is going up. And then the very last thing we want to be able to tell about the graph is something called even or odd. Okay, so even or odd. An even graph, the end behavior ends in the same direction. So here in example 3 and 4, in 3 the ends are going down on both sides, and 4 the ends are going up on both sides, so these two graphs we would call even. And then odd graphs are when our ends end in opposite directions. So like example 1 and 2, the ends go in opposite directions, so those two would be called odd. So that's the way how we're going to be describing our graphs. So we're going to do a couple of examples like this. So we're going to describe the end behavior, determine whether it represents an odd or an even, and state whether the leading coefficient is positive or negative, and then state the number of real zeros we'll discuss at the end. So 5 here. First off, notice that these ends are both going the same direction. They're both going down, so it means it's even. Since the right-hand side is going down, it means that we have a negative leading coefficient. And then our end behavior here, since both sides are going down, f of x would approach negative infinity as x approaches infinity, and f of x would approach negative infinity as x approaches negative infinity. So those both get filled in with negative infinity since they're both going down. Stating the number of real zeros, that's just simply how many times it crosses the x-axis. So here it crosses once, twice, so we would say there are 2 real zeros. Alright, example 6. Notice that our ends are going in opposite directions, so we would call this one odd. On the right-hand side of the graph, it is going up, so this would have a positive leading coefficient. The end behavior, f of x approaches what as x approaches infinity, and f of x approaches what as x approaches negative infinity. Well, as x approaches positive, that's the right-hand side, this is going up, so we'll say positive infinity. As x approaches negative, that's the left-hand side, so we'll say negative infinity. And then the number of real zeros, here we're just crossing the x-axis one time, so this has 1 real zero. Stay tuned for one last example here. Lastly, this one, we're both going up, so they're going in the same direction, so we would call this one an even graph. On the right-hand side, now notice, this graph we don't see on the right, but we can imagine that this would continue going up, and so on the right-hand side it would eventually be in the positive. so this has a positive leading coefficient. End behavior, these are both going up, so that we know regardless if we're on the right hand side of the graph, so as x approaches infinity, or on the left hand side of the graph as x approaches negative infinity, since these are both going up, we'd fill them both in with a positive infinity. And then the number of real zeros, looking here on the x-axis, this graph never actually crosses it, so we have no real zeros. Alright, so that's how we're going to be analyzing our graphs.